Hello everyone. I hope I'm audible to you guys. Hello. Okay, good. I'll now share my screen. For the week one, there were three lectures. The first lecture was Four Forces of Nature, Intermolecular Forces Timeline, the Leonard Jones Potential, and the second And the second lecture was about classification of forces and pair potential, strong intermolecular forces, chemical and physical bands, van der Waals forces, dispersion forces and steric repulsion, hydrogen bond, and hydrophobic interactions. The third lecture was about thermodynamics aspects of intermolecular forces, self energy and pair potential, and Boltzmann distribution and chemical potential. Submitted uh, week 1 assignment. Can someone, can you guys respond? Not yet. Okay, okay. So I just have this one question. I hope you guys can see. So here we have to calculate the force of gravitation between Earth and Sun. Given the mass of the Earth is 6 into 10 to the power 24 kg and the Sun is 2 into 10 to the power 30 kg, and the average distance between the two is 1.5 into 10 to the power 11 meter. So can you guys solve and tell me what you think the answer is? A similar kind of question is given in assignment 1 as well. So I'll give you some time to solve this and let me know the answer. Could anyone solve for this? Um, yes, Satrupa, I would try to get some sample problems next time. But today I don't have, except for this one question. So I'll try to get more problems for week 3 and for week 1 and 2, because those US already would be done with those tests. We'll just solve the assignment problems for those two. So anybody could solve this? Or anyone has any other doubt that we can go through?
Ma'am, can you discuss about the derivation?
Sorry?
And the few derivations I didn't understand. So
Uh, I can't hear you properly. There is a lot of noise in your voice. Some derivations. Uh, I see. Um, actually, okay. Sakshi is writing 5.33 into 10 power 32. Um, the answer would be 3.5 into 10 power 22. I don't know how you got 5.33. So for this question, the G would be 6.67 into 10 power minus 11 Newton meter square per kg square, right? And then we have M1 as 6 into 10 power 24 kg and M2 as 2 into 10 power 30 kg. And the R square would be 1.5 into 10 power 11 whole square. Right, so if you just multiply 6.67 for the G value into 6 into 2, you'll get around 80, and then 1.5 square is 2.25. And then the rest of the values, that is 10 to the power minus 11 for G into 10 power 24 into 10 power 30 would give you 10 to the power 43, and 10 to the power 11 in square would give you 10 to the power 22. So if you subtract 43 minus 22, you'll get 21, and then 80 divided 80 from the top and 2.25 for this r square would give you 35.55. So basically the answer will be 3.5 into 10 power 22. So I think you made some mistakes in the calculation. Yeah. Also, Rajdeep, for some derivations, I had few doubts on it. Okay. Uh, right now, I don't have the materials handy, so it's a bit tricky to discuss because I am not prepared beforehand. But I'll surely help you next time on the TA session. Or if you can write me your uh, doubts in which derivatives you had problems, I'll try to solve it properly, step by step, and then upload it on YouTube so that you can access it. Is that fine?
ma'am, how do I like contact you if that's the case? Like, how do I write to you? The
Uh,
how?
I'm asking you if you can write here as well, so that
Okay,
I'll keep a record of it and then I'll solve it. And while uploading this session, I'll upload the derivations for those as well.
okay, fine.
Yeah. So you just need a step by step solution, right? Just to understand how it is going or what.
Exactly.
Right. Okay. But from what I've seen from the assignment problems and all, it's mostly the end formula based. But sure, it helps if you know the derivation as well. Okay, you can write in the comment section all your doubts, and then I'll try to solve those and I'll upload. And if anybody else has any doubt, then you can also let me know here. So the G here 6.67 into 10 to the power minus 11. And then we have our both masses. In the meantime, you guys can post your doubts in the comment box and then I'll try to go through those. So this is what I was talking about, 6.67 into 6 into 2 would give you a value of around 80, and then 1.5 squared 2.25, and then if you have 24 plus 30 is basically 54 minus 11, that would give you 10 to the power 43 at the top, and in the bottom you have 10 to the power 22. So this would give you 35.5 to 10 to the power 21, which is basically 3.5 into 10 to the power 22 Newton. So when solving these questions, also try to look for the units so that everything is in place. Here we don't need to change the units because it's in meter. Otherwise, if it's in kilometer or feet or something else, you need to change it to meters so that everything is balanced. Okay. Uh, uh, you, uh, I think Rajdeep has still not written about his doubts. So
One second, ma'am. I'm getting it.
I'm also posting my mail ID here. So just a second. Yeah. So if you find more doubts also, you can write me here, and then I'll try to discuss in the next session as well.
Thank you so much, ma'am.
Welcome. We'll look into week 2 assignment. So before that, in week 2, 3 lectures were covered. Lecture 4. In lecture 4, surface energy or surface tension was discussed, wherein surface tension between two different medium, work of adhesion and cohesion in vacuum was discussed. Further, thermodynamics of interfacial energy. So here the how surface energy is related to enthalpy or Gibbs free energy is discussed, which is given by Maxwell relation. So the surface energy gamma is related as change in enthalpy delta H per unit area, change in area, PNN, where T is temperature, P is pressure, and N is the composition. Excuse me. Plus temperature into change in surface energy per unit change in temperature, delta gamma by delta T, which is here A P N. Okay. After this, then the interfacial energy or interfacial tension was discussed. Here comes the Duper equation. Duper equation, where surface tension between 1 and 2 is given by surface tension or surface energy of 1 plus surface energy of 2 minus W12, which is basically uh, work done to separate two different liquids or work of adhesion. So gamma 12 equals to gamma 1 plus gamma 2 minus W12. And then they discussed about, and then the work of adhesion in the third medium was discussed, wherein a change in energy in two different media, 1 and 2, in medium 3 was discussed, wherein we get a equation 1 W132 equals surface energy of 13 plus gamma 23 minus gamma 12. Now this work of adhesion can be either positive or negative and is also referred to as spreading coefficient S. And next was lecture 5. So in lecture 5, wettability was discussed. Young's equation, wettability in contact angles, wettability in spreading, effect of heterogeneity on wetting, and contact angle hysteresis. So basically, wettability or wetting the surface, there is a if a droplet of water is placed on a surface based on the angle made by this water droplet, if it is 0 degree, it is uh, if it is 0 degree, then it will be complete wetting. If it is less than 90, if it is less than 90, then still it is partial wetting. And if it is more than 90, then it is less than 90 partial wetting. If it is more than 90, then it is non-wetting. So these things were discussed, and then the Young's equation was discussed, wherein the angle made by this droplet with the surface, the theta, cos theta, is given by, uh, so here this will be surface in between liquid vapor, between solid vapor, and this is between solid liquid. So we get a relation as cos theta equals gamma SB minus gamma SL by gamma LV. By gamma LV. And then the chemical heterogeneity between surfaces and physical heterogeneity, these things were discussed in the contact angle hysteresis. So contact angle hysteresis is basically, it occurs when the free energy of behavior between free energy behavior between different wettability regime. So the contact angle theta at advancing and contact angle the contact angle theta at receding contact angle theta and the advancing contact angle theta are different. So this is called as contact angle hysteresis. Next, in lecture 6 discusses about work of adhesion and cohesion. Work of adhesion is basically work required to separate two different liquids, 1 and 2, whereas work of cohesion is work required to separate same uh, same liquid, 1. And then adhesion in biological systems was discussed. Further, the Chekiar and Hirsch theory of adhesion mechanics, which basically tells about when there are two different spheres of, let's say, R1 and R2, uh, and with elastic moduli K and surface energy W12 per unit area. So when these two interact together, they will flatten under external force F, and the final radius A is given by A cube equals to this r by k whole into under root 3 by 2 pi rw pi rw plus minus under root f plus minus 3 by 2 pi rw 3 by 2 pi rw. And then adhesion hysteresis, similar to the contact angle hysteresis we discussed, wherein the interacting solid surfaces also have both advancing and receding contact areas with different values of work or surface tension. Now we'll discuss week 2 assignment problems. And this is week two's assignment. Adhesion mechanics of two rigid surfaces can be related by Hertz theory, Jacquier theory, Stern layer, or Giri-Falco theory. The correct answer is Jacquier theory. Then what is the surface tension or surface energy? So here it is force per unit length. Which of these have lowest surface energy? So Teflon has the lowest surface energy, which is why uh, the droplets are formed. Droplets of water are formed instead of coating it over. And then the contact angle theta, it is measured by the angle between gamma SL into gamma SV. So cos theta is given by okay, this cos theta is between this is the liquid, this is our solid, and this is vapor. So uh, this will give us gamma SL, and this is SV, and this is LV. So between SL and LV, the theta angle is formed. Next, Young's tuple equation relates which of the following? So here the correct answer would be work of adhesion, interfacial tension, and contact angle. And the next question, spreading of a liquid on the surface will occur spontaneously if which of these? So if S is greater than 0, then the liquid on the surface will spread spontaneously. And metastable non-equilibrium state is the function of all of these: surface heterogeneity, alteration of surface properties due to contact with liquid, and adsorption over the surface. So as the next question, wettability of surface with physical heterogeneity is explained by Wenzel equation. What are the difficulties in measuring the surface tension of solids? Here the answer would be A. All the applied work does not reappear as surface free energy. And this is the last question. For N-hexane diiodomethane system at 25 degrees Celsius, calculate the surface tension 1, 2 in this form. So here surface tension 1, 2 would be gamma 1 plus surface tension 2 minus work done 1, 2. So here again this 1, 2 is basically 2 into gamma 1 dispersion 2 dispersion plus 2 into polarity gamma 2 polarity, and then it is the square root of this. Yeah, so here for this there is no polar solvents involved, so this term would be 0, and then we have gamma 1 gamma 2 and this term. So basically that is so in the lectures there was a table given where this surface tension for these systems N-hexane and diiodomethane are given. So first is 18.4, and for diiodomethane it is 50.8.
Ma'am, for the exam, do we have to memorize the whole table, the standard values, or will it be
uh,
given in the question?
I'm not really sure, but for the exam I think the table as a reference might be given.
And what about the calculators?
What?
Can we carry, can we carry our calculators?
uh, that is I don't know if it is if this kind of uh, mathematical problems are involved, they'll allow you, but I don't know if they'll ask you to solve the using the calculator in the system, or they'll allow you to carry your own calculator. So
Okay, okay.
you have to go to a center and give the exam, right?
Yes.
Yes, so it will be dependent on that. So yeah, so this will give us 69.2, and then we have this as 2 into this value will be 30.5. So the final would be 8.06, and then that is how we get our answer option A, 8. So just a second. We can use the system inbuilt calculator. Okay. Thank you, Jai Prabhakaran. Uh, okay. Now these were some of the sample questions I prepared for this week. So this was the first question. If a material is hydrophilic, which of these would be true? Can you guys answer? I'm still audible, right?
Yes.
Okay. So if a material is hydrophilic, which of these would be true? So here the correct answer would be surface energy is high. So surface energy is related to the hydrophilicity as lower surface energy, it is more hydrophobic, higher surface energy, it is more hydrophilic. So here the correct answer would be option B. Next, which of these is detachment method for determining surface tension? Have you guys gone through week 3 lectures? Okay, so here the correct answer would be Wilhelmi slide method. Here a plate is used and that is dipped in the solution and then it is pulled out, and based on the force the surface tension is determined. Whereas in rotating drop method and pendant method, these are static drops method for determining surface tension, and flow method is a dynamic method. Only the Wilhelmi slide method is a detachment based method for determining surface tension. This is the next question. Which of these instrument is used for measuring surface tension in detachment method?
A.
No. So here the correct answer is tensiometer. So as I said, the detachment method is using force to pull it out. So the tensiometer is used. Goniometer is used for the sessile drop method. And here is our last question. So the contact angle can be used to determine whether a material is hydrophobic or not. Suppose the surface tension between the water and vapor is 19.6 millinewton per meter, between water and material is 22, and between vapor and material is 45. Calculate the contact angle and answer if the material is hydrophobic or hydrophilic. I'll give you guys some time to go through this question and then we'll solve. Or you guys can also solve and let me know what you think the answer is. Was anyone able to solve this? Or is anyone even working on this? Shall I wait or shall we go ahead and solve this?
You can solve it.
Okay. So as we had gone through a previous question, the cos theta here, the angle theta here is dependent on these two, and by the Young's equation it is given as gamma solid minus SV minus gamma SL by gamma LV. So this will be SV here is given as 45. That is the vapor and material, that is solid and vapor, and then SL solid and material, sorry, water and material, that is 22, and then we have LV, which is water and vapor, 19.6. So this will give 1.17 around, which basically corresponds to theta of 0. Now if theta is 0, what would you say? The material is hydrophobic or hydrophilic? Okay, so the material is hydrophilic. If contact angle is less than 90°, the materials are hydrophilic. If it is more than 90°, they are hydrophobic. Okay, so this was all I had for today. And I'll try to bring in more such questions in the next week if possible. And do let me know if you guys have any other doubt. Can you repeat the previous question? Which question you meant? Jai Bhaskaran, Jai Prabhakaran, sorry. Which question you want me to repeat? I hope I'm still audible. Can you please write which questions you want me to repeat? Surface tension and detachment method. I see. So there were two questions basically. Which of these method is the detachment method? Here the Wilhelmy slide method is basically uses a plate and then that is pulled out from the water. That is the detachment method. Rotating drop and pendant method are static drops method, and flow method is a dynamic method. And this was another question on detachment method as to which instrument is used for measuring surface tension. So here tensiometer is mostly used for both plate detachment as well as ring detachment methods. Whereas goniometer is used for sessile drops method. Microscope imaging is mostly used to take a picture of the droplets and then measure the contact angle from there and then determine the surface tension.
And can you go to the previous question?
Sorry, previous question.
Can you, yes.
Sorry, do you want me to go? What do you want me to do here?
No, no, it's okay. You got it.
Okay. By the way, I'll be sharing this presentation will be shared with you people. Also, this record session is being recorded and it will be uploaded on YouTube. You guys can refer whenever you want. Okay. Next week probably your deadline would be over for this week 3. Yeah, for week 3 assignment submission, the deadline would be over by then. So we'll solve week 3 questions, and also I'll prepare some sample questions for week 4. I hope this session was useful, and if anybody has any other doubt, you guys can ask, or we can close this session here. Okay, you guys can leave the session if you don't have any doubts. Okay, anyone has any other doubts? Okay, sure. So Rajdeep, also you can write to me on this mail ID, and then uh, I'll try to upload those doubts. And if I'm not able to upload, then also we can discuss it next session. So yeah, do write me in on the posted mail ID. And if nobody has any other doubts, then maybe we can close this session today. And I'll try to prepare more, come up with more sample problems for the next session. Yeah, you guys are feel free to leave, or else you can stay if you want to ask any questions.